Okay, so in this video we want to look at some important examples to do with limits and continuity. This is a concept that some students find very difficult, so it's worth looking at some interesting examples where some maybe non-intuitive behavior occurs. The most important example I want to consider is the following function. So we define f to be the function x for positive values of x, negative x for the negative values, and at 0 this function is 4. Okay, so this pretty much agrees with the absolute value function everywhere except the origin. At the origin, at x equals 0 the function is 4. So the question that I'm going to ask is, what is the limit as x tends towards 0 of f of x? So as we approach x equals 0, what does the function approach? Now, a common thing that I am seeing from students is, well, I can understand why they're doing it. They just say, oh, I know what f of 0 is. F of 0 is 4, so this limit has to be 4. This is entirely incorrect. The limit has nothing to do with what happens at the specified point. So it doesn't actually matter what happens at f of 0, it's near f of 0. So if we zoom in to this function, so we just zoom very close to x equals 0, but don't actually look at 0 itself. If we just look in some small neighborhood, it looks like the function is converging to 0. And that's what the limit is. You can't tell that the function is going to jump rapidly to 4 if you look very close to 0 but not at 0. So this limit is not going to be 4. The limit as x tends to 0 of f of x is going to be 0. This is related to another conception or concept that people are struggling with, which is continuity. So let's look at a function defined on the reals to the reals. So this is one such example. We'll say that a function of this type is continuous at some point if the limit as x approaches that point is actually equal to the function value. Here, this function is not continuous at x equals 0, because as we approach 0 along the function approaches 0, but it does not equal 0, it equals 4. So continuity, examples of continuous functions are things of this form. Polynomials provide examples of continuous functions, which you can check. Typically, when we're given examples of discontinuous functions, we get given something of this type, where the limit doesn't exist and therefore it's certainly not continuous. Let's say here's our point P, and this is our f. What makes this example so difficult is that the limit does exist, but the function is still not continuous. So really keep this thing in mind when you're looking at limits, especially of maybe more complicated piecewise functions of this type. And make sure you fully understand this definition, because I see a lot of students just think, oh, if you can draw the graph without taking your pen off paper, then that's enough. But you really need to understand this definition, otherwise you probably wouldn't have made these mistakes. Okay guys, I thought it'd be important for everyone to see these types of examples. So if you liked this video, please hit the like button, and if you want to see more of this type of content, I'd appreciate it if you subscribe to the channel. Thanks guys.